And on to page 3 of 7.6. Same instructions, just starting to take it up a notch in what the problems look like at the beginning. And again, I try to pick someone's in your notes that will help you deal with the assignment. But some of you who are wanting to kind of step it up a little bit, be more prepared for the exam, you might want to try the assignment, try some of these harder problems, and then if you get stuff, if you can't get them on your own, come back and watch some of the video, because some of you need to kind of stretch your brain a little bit and get it ready for dealing with fresh, new, different looking problems, because that's what an exam is. It's problems you've never seen before. So some of you might want to take this opportunity to, before you watch me do it, maybe you try the ones in the notes first. So not even waiting for the try problems down at the bottom, but you try them on your own and see if the video can be just your resource as a backup. That might be a great way to get yourself more ready for the exam. Totally your choice though. So here we go. Number 30 on 463. Same steps as before. You're going to rearrange to standard forms, which means you're going to want it in ax squared plus bx plus c equals 0. That's the critical point, is to set it equal to 0. Then you're going to factor our boringly good method of, hey, is there a GCF? And then how many terms? Because whether it's 2, 3, or 4 will determine where we go next. And then you're going to set each factor to 0, and that is using our zero product principle. Because when you have factors, you've got something times something equals 0, because we set it up in standard form. And then if you have something times something equal to 0, then the zero product property says, well, not property, sorry, principle. I slipped back into my old ways. When you have something times something equals 0, the zero product principle says, well, either the first thing equals 0 or the second thing equals 0. So that's why we get to do step 3. And then you can solve each equation for x, and these should feel like easy 1 or 2 step equations that you got really good at in Math 60. And then of course you can check using substitution. Okay, so let's look at what they look like. Number 30, x squared equals 14x minus 49. And again, remember our strategy. As things get more difficult or seemingly more difficult in your assignment, you can always pause before you try to jump in and create new math and panic and all those other things we tend to do when we see something that we aren't used to. Ask yourself, well, what's so different about this equation than the one I saw before, the earlier examples? And what is different is the fact that there's stuff on both sides of the equal sign. It didn't start equal to 0, which is what we want. We want it equal to 0. So now we're actually having to do step 1. We do have to rearrange to standard form. So the difference here, it's not given to us in standard form. We're going to rearrange to get it there. So I'm just kind of used to having everything on the left. So I'll go ahead and subtract 14x from both sides. At the same time, I'm also going to add 49 to both sides so that I can get this thing equal to 0. So on the right side, I'm going to have 0, and I'm going to have x squared minus 14x plus 49 on the left side. I tried to keep those equal signs kind of lined up there. But you move things over by doing the opposite operation. I've got x squared minus 14x plus 49. So I've got it in standard form, so step 1 is done. Next, I do, is there a GCF? Because I'm going to factor. So is there something that all 3 pieces, now don't look at the 0 part, we're just trying to factor the one side, okay, the quadratic side. And there is no GCF. How many terms? 3. I've got 3 terms that I'm going to try to factor. So I have a choice. I can guess and test by just drawing the parentheses and putting numbers in until it works. I could convert this to 4 terms, or I could see if this is a perfect square trinomial. I could use some of my skills from 7.4 leftovers about that. So let's look to see what we've got here. I am going to check to see if it's a perfect square trinomial. So that means I look at my a value, which is 1, and 1 is a perfect square because I can take the square root of 1 and get a nice number. In this case it's still 1. My c value is also a perfect square, 49. because I can take the square root of 49 and get a nice number, 7. 7 times 7 is 49, 1 times 1 is 1. But the real clincher of whether or not this is a perfect square trinomial is if that b value, 14, if that's equal to, I'm wondering if that's equal to twice times our square root of a times our square root of c. This is our square root of a, 1. This is our square root of c, 7. So is 14 2 times 1 times 7? Yes. Okay, so this is a perfect square trinomial, and I'm already running out of room. Yikes. So let's see, I think I'm going to check the screen how much I can see here. I think I can squeeze this over. We might slide over into this other spot here. So I have a perfect square trinomial, which means this is going to factor to x and 7, x and 7. And because the middle term is negative here, it's a negative value, that means they're both going to be minus because we always match the sign of the middle in a perfect square trinomial. So what I have here is in factored form, I've got x minus 7 times x minus 7 equals 0, which means either the first factor equals 0 or the second factor equals 0 when I have something times something, this is multiplication here, equal to 0. So now I'm using the zero product property. So we factored, and now we're going to set each factor equal to 0. So x minus 7 equals 0, or x minus 7 equals 0. And because the factors match, you don't have to do this twice. Okay, this is already the same thing that we're already figuring out. So we solve x minus 7 equals 0, and we get x is equal to 7. Check that back in the original equation. 7 squared is 49. 7 times 14 is 70, 98 minus 49. That equals 49. So 49 equals 49. That's a true statement. 7 works in the equation. So I'm going to go ahead and put that in my solution set. Wrapped it up neat like a bow. Make sure it works. Make sure it fits. So our answer is 7.